Well, we have to find many technological solutions, but all these solutions have their costs. So the people who are working on the engineering disciplines or the scientific disciplines, they can only talk to us about the technologies, the innovations in technologies which could be needed. However, the economic disciplines then can show that what are the costs of these changes, and that this would have a huge impact on the competition among the various energy forms, and this would have the consequences on the trade of energy. And so there are a lot of linkages which are there. So when we integrate these disciplines and the knowledge of disciplines, then all this new additional value comes out in terms of how we can solve this problem at the least cost.
I like to think of models as being like maps. Often people want to say, let's build the model of South Africa. Say, well, you wouldn't ask for the map of South Africa. It would depend on what you wanted to do with the map. So a map of Cape Town would be very useful for finding your way from the University of Cape Town to Adderley Street. But it wouldn't be very useful for getting you to Durban. You want a different map. And so one of the things we have to do with models is say, what are we trying to use it for, and what's the most appropriate? We wouldn't say the map of Cape Town is wrong, it's just not the useful map.
EMACLIM is an innovative CG model because it accesses or analyzes traditional economic indicators like GDP or unemployment, but not only this, but also other social indicators like income distribution, poverty, and we can draw the Gini coefficient for different scenarios, climate policy scenarios. Well, EMACLIM can help policymakers because the modeling objective of MAPS Brazil and the modeling objective that we are considering is to propose a mitigation scenario that is going to be reached at the least cost possible. So what we propose is that Brazil is going to continue to grow and in a more equal way, and also reducing GHG emissions.